Hello everyone, welcome to my channel. This is Naresh. In today's session, we'll talk about operational amplifier, which includes the basic introduction of the Opamp and pin diagram and block diagram and voltage transfer characteristics. And the definition of the Opamp is it is a form of differential amplifier that responds to the difference of two input signals. In other way, like one more definition for this is the op-amp is the direct coupled high gain electronic voltage amplifier with differential input. Yeah. If you see the definition carefully, op-amp is a differential amplifier that responds to the difference of two input signals. If you see the schematic of operational amplifier, it has two input pins. One is non-inverting pin, one is inverting pin. If you give the voltage at this pin and this pin, this difference it will amplify and produce at the output, the basic definition. And one more is it is a direct coupled high gain electronic voltage amplifier with differential input. How we achieve this high gain we'll see in the next topic. In block diagram we'll see how we can achieve this high gain by using which amplifier we can achieve this high gain. We will see. If you see here, this is IC 8-pin IC configuration of the op amp. All pins are useful here. Like it is one is offset null, inverting, non-inverting, and this negative V is nothing but minus V saturation will call. This positive will call as a plus V sat. And this set of pins mainly will use is inverting, non-inverting, output, positive VSAT, negative VSAT. The what you call use of the offset null pins are when you are operating op-amp in non-ideal conditions, means in practical applications, even though we are not giving any input at these two pins, we will get the some output. So to nullify the output when no in to nullify the output voltage when there was no input connected, we can use these two pins offset null. By using these two pins we can eliminate or nullify the output voltage. Means even though you are not giving the input at input terminals, we are getting some output. By using offset null pins we can adjust or we can nullify this output voltage to 0. The main purpose of these two pins is to nullify the output voltage when there is no input connected. And regarding these 5 pins, yeah, this is inverting input, this one is inverting input, this is non-inverting input, this we'll call as a plus VCC or VSAT or positive power supply, and this we'll call as negative PWE or minus VSAT or negative power supply. This pin will call output. So if you see why these two pins are called inverting and non-inverting, if we take one input, so I will take one input signal, this one, this I will take a VI, and this I will apply to negative terminal of the op amp. So what I will get is the negative input terminal is inverted by 180 degree and output I will get this. So if you see this positive portion, it's coming negative portion, this negative portion is coming here positive portion. So the input to output we got 180 degree phase shifts. That's why we will call this input as a inverting. Whatever the portion we are giving, it is coming inversion. So that's why we'll call as this input is inverting. So same input I will give to pin number here, non-inverting input. So what I will get is the output I will get a amplified version of input I am giving. Suppose you take input I given some 2 millivolts, output I got 5 volts. So positive portion is appearing at positive portion only, negative portion with amplified version we are getting at negative side only. So here if you see from here to here we are getting 0° phase shift. So when we give input to the non-inverting input we are getting same like input, but only thing is we are getting amplified version and there is no phase shift. So that's what we'll call as the non-inverting input, this will call as the inverting input. And the main functioning of these two are supplies. It's like whatever the input you give, if you connect 5 volts here, if you connect, suppose I am giving plus VCC equal to plus or minus 5 VCC, I will give plus 5 volts. If my input is 2 millivolt, I'm getting after amplifying circuit is some 10 volts. But in this case, my output will saturate at only plus 5 volts because I have connected 5 volts to the VCC terminal. So what does it mean? The maximum output voltage we will get at output of the operational amplifier is plus VCC in positive case, minus VCC or minus VWE or minus V saturation in negative case. This is the importance of these two biasing power supplies, and output will take at this pin. This is the 5-pin configuration of the ideal op-amp circuit. We'll go to previous section. So here we discussed power supplies both and power supply both these two and inputs and outputs. So next we'll see block diagram of operational amplifier. Till now what we see, whatever the external pins what we are connecting till now we are discussed. Now we will see the internal diagram of the or block diagram of the operational amplifier. This is the main important topic for the interview point of view, because here we can expect draw the block diagram of op-amp and explain each stage of the operational amplifier and what is the significance of each stage they can ask. And if I miss one stage, for example if I miss level shifting inside the op-amp, what will happen? This is the most important topic and we can expect so many interview questions from this point, this block diagram. So now we'll go through block diagram first. So this operational amplifier block diagram consists of mainly 4 stages. One is input stage, second one intermediate stage, third is level shifting stage, fourth one is output stage. If you see inside, first these two stages are differential amplifier. This is the most important stage for the operational amplifier. First and second stage are differential amplifier, third stage is level shifting, and fourth stage is output stage. So here we will see significance of each stage. If you talk about first stage, what is the importance of the first stage in the internal block diagram for op-amp is it will provide high input impedance. To provide very high input impedance, and this stage sorry I forgot to tell, this is dual input balanced output differential amplifier only, but it is dual input balanced output. So dual input means we are giving 2 inputs to the differential amplifier, balanced output. So I will explain you 1 minute here. See, balanced output is nothing but, if you take this is op-amp, I told you 2 power supplies you have. If you take output here, this is balanced output. If you take output at one power supply and one ground, this is V0. If you take like this across output voltage to one ground, this we call as a unbalanced output. So output will get only output pin from output pin to ground. If you take this unbalanced between the 2 power supplies, if you take this is balanced output. So here it is dual input. Here it is dual input and balanced output. So this stage is very important for providing the high input impedance as well as high CMMR, CM, common mode rejection ratio. This I will discuss you later. Why CMMR high required for the operational amplifier. So first stage is mainly responsible for to provide the high input impedance of the operational amplifier, to provide high input impedance as well as to provide high CMMR. So second stage if you see, this is dual input unbalanced output. So that's why we see output is only one we got out from the this stage. So this stage is important to provide high gain for the op amp, high gain for op amp, high gain. The responsibility of this stage is to provide the high gain for the operational amplifier. And third stage is level shifting. This level shifting stage is nothing but the emitter follower using constant current source. So what is the responsible of this stage is to provide DC level, to make DC level to 0. Because if you see the configuration of each stage, this is coupled through direct coupled. Because of direct coupling, we'll get the DC up to this stage. To make DC to 0 level, we will use the level shifting stage. The final stage is output stage. This is the power amplifier. This is complementary symmetry push pull amplifier. This is power amplifier and responsible to provide the high output, high level output to the high level, means it will provide the high in the sense it will give high power to the output of high power at output of the circuit. For this stage we will use power amplifier at this stage. This is the full discussion about the block diagram. So mainly the concentration of the importance of this block diagram is mainly differential amplifier and each stage what it will do, and level shifting and output stage. Now if you see the internal diagram of the operational amplifier, if you see this is inverting, this is non-inverting. So that's why positive I connected to V2, negative I connected to V1. Because of the high input impedance, this is ideal model. So whatever ideal model, the internal impedance is very high. So that's why there is no resistance inside. So it is like open circuit. So very high resistance. Because of that, the current entering into the op amp is always 0 for ideal model. So that's why I2 is 0, I1 is 0 at inverting and non-inverting input. And if you see the output side, this is voltage controlled voltage source. So voltage controlled voltage source, on which it is controlling the difference between these two terminals. Means output, if I take V0 as output, it is gain times V2 minus V1. This V2 minus V1 times, so this gain I will take, and this is V difference. VID is nothing but the difference of non-inverting to inverting. So V2 minus V1. This is the output at op amp we get is V0 is equal to gain times V2 minus V1. This is internal model of the circuit. This is VID, A times VID. So if you see the voltage transfer characteristics, we will take x-axis on input, y-axis on output. This input is difference of these two pins. So if you see up to this range, yeah, now I will tell you the output of op amp depends upon maximum output voltage at op amp will get, already I mentioned, plus Vset to minus Vset to plus Vset. More than this output voltage will not get. So that's why if you see the maximum saturating, it is saturating at plus Vset or minus Vset. Before that, if you see up to this range, it is operating in linear region, because this v naught is, I told v naught is a times vid. So from here, I will directly substitute v naught equal to a times vid times plus v set minus v set. So if you take vid, this is plus v set divided by aol divided by aol. This is important to work op amp as a distortionless amplifier. We should follow this condition. So this is only minus v set divided by aol point. This is plus v set divided by aol. This region only, this region will call as a linear region, and this region we call as a saturation region. These two regions are called saturation. To work op amp like amplifier, we should operate in linear region. To operate op amp in linear region, we should follow the we should satisfy this condition. If op amp work like as a comparator or in open loop, we'll use these two regions. This is all about voltage transfer characteristics. And if you see the ideal op amp characteristics, it has infinite input impedance, because Rin equal to infinite, because this is due to the input stage we have differential amplifier, and zero output impedance. Op amp should satisfy the voltage transfer characteristics. So for that one, we have R not equal to 0, because any good voltage amplifier, the output impedance is 0. This is, I told you, 0 common mode gain are equivalent to infinite common mode rejection ratio, CMRR equal to infinity. This I will tell you why we require a high CMMR in later stages. And the infinite open loop gain, AYL equal to infinite, and it has infinite bandwidth. These all are about ideal op amp characteristics. Yeah. Now, one interesting and interview question is, what is the significance of 741 in 741 IC? We have this 741 IC. What is the significance of 741 in 741 IC? For that one, for the reason is, if you see, it is 8 pin package, because we have 1 2 1 1 2 3 4 5 6 7 8 pins. 8 pins are there, but in that, if you see, the working pins are only 7, because no connection pin is there. So 7 is pins used in op amp. Next, what is 4? The working signals like inverting, non-inverting, plus V, minus V. This is minus V sat, this is plus V sat, and inverting input, non-inverting input. These are the input and what you call providing inputs to the op amp. So that's why we have 4. 4 is negative terminal in non-inverting terminal, plus V sat, minus V sat. That's why we'll call 7, and next is 4, and final one is what? What is 1? 1 is we have only one output of op amp. So that's why we'll call as 1. So all these three included in 741 IC. That's why we'll call this IC is 741 IC. Yeah, next session we'll see virtual ground and how we can use inverting and non-inverting op amp with finite and infinite loop gains and buffer amplifier. Thank you for watching.